we need to prove this function is continuous on this closed interval. The bracket here means that -1 is counted and 1 is also counted. If we use parentheses, that point will be excluded from the interval. Okay. So far, first, in order to solve it, we need to find the domain of the function. The domain is where the function is defined. And the root function is defined when here, this is the square root. It is defined when the term under the radical sign here is positive. Therefore, we need to find them. Okay. And we do some algebra inequality stuff here. We found that this function is defined from -1 to 1. So this is the domain of our function. That is one way, right? Then we prove, okay, for any value of x, consider first the interval, the open interval from -1 to 1. For any given number a between this interval, right? Let us find the limit when x approaches this a. And we apply some limit laws, step by steps. We first do the subtraction law, right? It will be the limit of a constant, subtract the limit of the radical sign. Then, this is a radical sign. We can use the law related to that term, right? Then we can take the limit to this under the radical sign and compute it. And here we got this term. It is exactly the definition of the function at the point A, right? Then it's satisfying the definition of continuity. It means that the limit of this function when x approaches a is fa. Then we conclude that this function is continuous in this interval, okay? This open interval. So therefore, from -1 to 1. Okay, we've done this part. And we need to show that it is continuous in the closed interval, which includes -1 and 1. Okay, so then the second case, we should consider, what is it? We need to consider at the point -1, right? Then we need to, okay, from this interval, the function okay, so far we proved that for any point between this interval, it is continuous. Now we need to consider at this specific point, right? So whether it is continuous or not. So in this case, should we consider the right-hand limit or the left-hand limit? Left. Left? Any other idea? Right. Why? Because we're considering this interval, right? And the point -1 here, it is defined when x is on the right side of -1 only. That is why we consider the right-hand limit of this. Okay? Good job. Now you see why we do this, right? So, and again, we substitute this, the formula of this guy, it is 1 subtract 1 minus x squared here, right? If I remember correctly, yes. And we do the same thing, okay? apply some laws and whatever, etc. And in the end, we reach this point, okay? It will be, what is it? Mm-hmm. What is it? Huh, be careful. Yes, very good. And anyway, this guy will simply be 0, right? So at the end, it will be 1. Yes. Is it equal to the function at 1, the evaluation of the function at 1? -1, I mean, yes. It is equal, right? So therefore, it is a right-hand continuous at this point. Okay, very good. Is there any question here? You know why we consider the right-hand limit only? Okay. Now one more point left. What is it? Yes, very good. So the third case, when a is equal to 1, so should we consider the left-hand limit or the right-hand limit? Very good. Left hand in math notation, we write it negative here, right? Good job. Then we do the same things, do some algebra, apply some limit laws. And in the end, it will be what is it here? Yes. Good job. Or anyway, it will be 1, and it is exactly the evaluation of the function at x is equal to 1. Okay. Therefore, let us call this 1 star here, the first star, and the second stars here, and the third stars here, right? From 1 stars, 2 stars, and 3 stars here, we conclude that the function fx is continuous on the interval from -1 to 1, the closed interval. Okay. Are we good now? People on Zoom, is it okay? Okay. Good job. Now, take a look at the notes I gave you in the next slides. Thank you.
Why do you have the problems from the MP2 on the old test?
For the old test, I will record the explanation of that question and send you the link. It will be in YouTube, the topic YouTube in within Moodle, and go to the channel, you'll see it. Okay, I will explain it because it takes a long time. So we want to save time here for other problems. Okay, and tomorrow I will give you one example which is similar to one of the A, B, or C, D. Will be
It's only one question.
One question will be a quick quiz, no stressful. Okay.
Thank you.
Very good. So, and okay, before we go to the next problems of the previous lectures, we review the trigonometry stuff, right? And you still remember the unit circle? Okay, I hope so too. Anyway, we'll do a quick recap here. So this is the unit circle, and the axis here, is it a cosine axis or sine axis here? Cosine. Very good. And here is the sine, and the value of this will be 1, yes. And here? Very good. Same things here. Okay. So the angle theta start here at 0, right? This is the positive direction or negative? Good. And here? Good job. Okay, imagine. In order to find, suppose we're given any angle alpha, then consider this small triangle, right? This is the origin O, the point P here, the point M. And we know that this right angle here, the cosine alpha, what is it? Perfect, OM over OP. Since it is a unit circle, OP is equal to 1, okay? Then this will become simply OM. So with this unit circle, we know that the distance from O to M is exactly the cosine of this angle. Okay. The same thing. Yeah, another review, right? Okay, if we call this point N here, then the distance from O to N, what is it? Yes. Very good. Sine, it will be PM, right? Divided by OP, which is MP. And this rectangle here, MP is exactly the same as ON. So quick recap shows that, okay, this distance will be the value of sine alpha. So in the future, for any given alpha, in order to find cosine, we just project to that, right? Sine or cosine axis. So now look at this. Some special triangle, which is very useful, super useful. So if we're given this right angle here, if this is 45 degree, this is 45 degree. A, B, and C. This is right angle here, right? How big is AB and AC? Yes, if this is AB is 1, then AC should also be 1, right? So if you imagine this triangle, special one, what is cosine of 45 degree? Oh, by the way, sorry. My bad. What is the length of BC? Perfect. Then from this one, what is cosine of 45? Yes, 1 over square root of 2. It is a lot easier to remember some special triangle, right? Sine of this one? Same thing, good job. Okay. And tangent so far. And here, suppose this is a special triangle where all the angles here are 60 degrees. 60. A, B, and C. We know that AB is equal to AC and BC, right? The special from geometry, we know that if this unit AC is 2 unit, this is 2 unit as well, Then let us call it H is the middle point here. Then what is the distance from H to C? Yes, very good. It is 1 unit here. And what is the distance from A to H? What is it? AH squared. This is a right angle, right? AH squared plus HC squared equal to what? Pythagorean theorem. Beautiful. AC squared. HC is given, right? AC is given. Can we find AH? What is it? Very good. Okay. Therefore, this small angle, it would be 30 degrees, right? So if you memorize this small triangle here, you can know the values of cosine, sine of 60 degrees and 30 degrees easily. Okay. What is cosine of 60 degrees?
1/2.
Thank you. Good job. Sine of 60. Yes, square root 3/2. How about cosine of 30? Yeah, square root of 3/2. And sine of 30? Yes. Now you can memorize all the special angles easily if you memorize these things, okay? Okay. Is there any question? Good. People on Zoom, is it okay? Okay, now, so go back to the unit circle here. If we go from 0 to pi/2, sine will be 1, right? See? Now let us play with some special angle. When alpha is equal to 0, alpha is equal to pi/2, and alpha is equal to pi, and 3 pi/2, right? And then 2 pi. Just play with these special ones. Okay. Look at the sine function. What is sine of 0?
0.
Yes, we project to the sine axis, it gives us 0. Then sine of 0 would be 0. How about sine of pi/2?
1.
Very good. Sine of pi?
0.
Good. Sine of 3 pi/2? Okay. And sine of 2 pi? Good job. Or simply 0, right? Then let us plot that some special points. We see that if we plot it here, and the y-axis, we call it the value. And the x-axis is, let us define here is x value here, y here. If this is 2 pi, and half of this will be pi right here, it is pi/2. Here 3 pi/2. Then we plot it into the coordinate. At 0, suppose the value in the y direction is 1 here and -1 here. Okay, at x is equal to 0, sine of 0 will be 0. Then where is it? Where's the point? Very good. At pi over 2, this point, right? Good job. At pi, go back to 0, right? At 3 pi over 2, good. And 2 pi, 0, right? So here is the graph of the sine function from 0 to 2 pi. Okay. If you continue going to the angle 2 pi plus pi over 2, it go back to 1 here, right? Just repeat the process. So we know that if we go this way, it will go up here, or you can plot some other point here. It just continue. So this is, yeah, or it continue this way. Okay, this is the graph of the sine function. So now let us play with the Desmos graph here. You see that it is exactly what we saw previously, right? People on Zoom, are you seeing my graph on Desmos? Okay, thank you. So see, it is exactly what we saw. This is 2 pi, right? 2 pi means 6 point something. 1 pi is 3 pi, 14, etc. here. So this is the graph of sine function. We see that it is continuous, right? And what is the domain of the sine of x? Very good. For any value of x in real lines, right? It is defined. What is the range of the sine function? Good. Beautiful. So how about the cosine function? Do the same thing, we're able to plot it, right? Good. And tangent will be sine divided by cosine, okay? Oh my God. What is it? Yeah, it is discontinuous. It is infinity disjunct, right? Discontinuity. Yeah, at vertical asymptotes. Very good. Thank you. You see it? Or if you go back to the unit circle here, as we mentioned last time, this is the tangent axis. Okay. This is positive infinity right here. For any angle alpha here, in order to find the tangent, just connect this point and the point on the circle to the origin and expand it. Wherever it cut, it is the value of tangent here. So we see that if the angle alpha here come closer and closer to pi over 2, when we connect it, it will cut at very top here, right? It goes to infinity. Okay. How about if the angle goes to come closer and closer to negative pi over 2? Yes, this is how you imagine the tangent. Okay, the graph of the tangent from negative pi over 2 to pi over 2, and for angle between these, the same story. If the angle is right here, then we connect the origin here, wherever it cut, it will be negative here. Okay, so that is why if the angle alpha is in the second quadrant here, the tangent will be negative. Thank you. Okay. Now, let us continue. So in this summaries here, we see that the function sine and cosine are continuous on R, okay? From definition. And similarly, the tangent function here is undefined at this point. pi over 2, negative pi over 2, or 3 pi over 2, negative 3 pi over 2, etc. There are many others values, right? And this is the quotient of sine and cosine. When is the tangent function defined? It is defined when the denominator is not 0, right? And the cosine is equal to 0. The cosine is equal to 0. Look at this. Cosine is equal to 0. It means when we project back here, it should be pi over 2 or negative pi over 2. Yeah, very good. Continue. That is why. So anyway, it is another review about continuous of sine and cosine function, trigonometry. Is it clear? Very good. Now we have this theorem, polynomials. What is a polynomial? Do you remember the definition of it? Polynomial P of x is written as a n x to the n plus a n minus 1 x to the n minus 1, etc. plus a1 x to the 1 plus a0 is a number. This is a polynomial. Okay? From the limit laws, when we take a limit of x to the n, we know that it is continuous, right? So suppose we're computing the limit when x approaches to any given number, a, of the function px here. It is the same as taking limit when x approaches a of this, the whole things here. Okay? Then which laws of which limit law should we use to find this limit? Addition, yes. And then some other laws, right? And then finally, we conclude that any polynomial will be continuous by proving this way. Okay? That is why we have the first properties here. So all polynomials are continuous on R. Okay? Second, rational functions. Rational function is the quotient of a polynomial divided by another polynomial, right? And it is defined where the denominator is not 0, right? So and they say that it is continuous on its domain. So wherever Qx is not 0, then it is continuous. And trigonometry functions is also continuous. Exponential function, root functions also continuous on its domain. Inverse of trigonometry function, logarithmic function. If you don't remember these, please go back to the course 1021 LSU, as I reference in the Moodles, and review these. Okay. And this theorem, f is continuous at the point B. This is tricky. And the limit of g of x when x approaches a is equal to b. Then the limit of f of g of x is equal to b. That is equal to f of b. In other words, the limit of a composite function, yeah, is equal to this. Is this theorem clear to you now? Just read it, digest it before we do an example. Is it clear now? Okay. Let us do this example. Evaluate the limit when x approaches 1 of r sine function of 1 minus square root of x divided by 1 minus x here. R sine function is the inverse function of sine. Okay? So do you remember this function, or do you need me to explain it a little more?
It's just taking sine and putting it over 1, right?
Yes, okay. So R sine is inverse of sine. So how to say it? If sine of x, suppose sine of x is equal to alpha, then we take R sine of the sine of x, both sides. Then here, R sine is inverse function of sine, and the left-hand side is simply give us x. Okay, just a inverse of sine. Or in other words, okay, look at this unit circle. Again, unit circle is very useful. We have to face it many times. This is cosine, this is sine is equal to 1 and -1. So if we're given here, the angle alpha is 45 or pi over 4. What is sine of pi over 4? Yes. Or imagine like the special triangle, right? 45 degree or pi over 4 here, sine will be 1 over square root of 2, or as you say, square root of 2 over 2, the same thing. Okay. Then our sine function is the inverse of that. It means that if we are given the value square root of 2 over 2, then what is our sine of square root of 2 over 2? Yeah, pi over 4, right? Okay. You see the difference between sine and r sine? Sine is that we are given the angle. We need to find the value. R sine is we're given a value. We need to find which angle gives us that value. Okay? That's it. And inverse function, because a function is defined, if we're given a point, then we can only find one value in the range. So therefore, inverse function, in order to find the inverse, it means it should be 1 to 1. Okay? 1 to 1, what does it mean? Yes, thank you. Any one input give us one output, and one output give us only one back our input, right? So therefore convention, R sine will take the value in order to cover all the values from -1 to 1 here, right? We convention is that, okay, the angle alpha here should take from -pi over 2 to pi over 2 only for the R sine function. Okay. Just 1 to 1. We don't take the value on the angle because you see that there is another angle here at 3 pi over 4. And sine of 3 pi over 4 also gives us the same value. It is square root of 2 over 2, right? But when we take the R sine function, we only take the values pi over 4. That is just a convention. Okay. Now, anyway, so go back to our example. Here, our sine function is continuous on its domain. Okay. Then can we apply this theorem here? In order to apply this theorem here, the function f should be continuous at this point, right? And the R sine function, we're given that this is a continuous function. Anyway, let us try to compute. Okay, in order to apply this theorem, we need to make sure that, okay, suppose let us find the limit of this guy. In this specific example, what is f and what is g? Very good, thank you. In our case here, let us call f of x here is the R sine function of x, right? And what is g of x? Yes, g of x is given as this term, 1 minus square root of x divided by 1 minus x. What does it mean when we say f of g of x? So it is a composite function. It means that we should evaluate the term inside first. Okay? It gives us, what is it? What is g of x here? Very good. Right? This is composite function definition. And then what is f of this guy? Yes. Arc sine of the whole thing. It's like the composite function is of f and g are two machines. First, we put x to the g machines first, right? And then we got a product, put this product into the f function here. This is composite function, right? Or in notation, sometimes we write it f composite g this way. Okay. Well, we review a lot of things. Haven't done that much. Is the concept clear now? Very good. Go back to the theorem here. So first, it means that we can take a limit before we take the limit of the whole thing, a composite function here. Let us take the limit of the first function, left limit of g of x, right? And in this case, it means that consider limit when x approaches 1 of which?
The inside 1 minus.
Very good. So how can we compute it? Very good. So we see that this term is very annoying, right? We multiply with the conjugate of this. And what exactly is it? Very good. Thank you. What is your name? I'm sorry. Emma, thank you, Emma. Good job. 1 minus square root of x, and the denominator is 1 minus x. If we multiply both numerator and denominator by the same terms, and the conjugate of this, which is, as Emma suggested, 1 plus square root of x, right? Okay, doesn't change anything. But now, which formula should we use? It becomes help me, please.
Distribute the two binomials to each other, which is 1 minus x.
Yeah, you distribute or use this formula. A squared minus b squared will be
Minus b.
right. Here, is it okay? 1 square is simply 1. Anyway, it will be,
Do the same thing.
oh yeah. We don't have to distribute the bottom, right? Just leave it this way. And what is it in the numerator?
1 minus x.
Good job. Okay, then what should we do?
Cancel out the 1 minus x.
Beautiful, thank you. We cancel it out. It becomes, thank you. Okay, now, can we substitute it?
Yes.
Yes, it is defined at 1 now. It becomes 1 over 1 plus square root of 1, which is 1/2. Thank you, good job. So at 1/2, now we consider whether the R sine function of 1/2 continues at this point. Is continuous at 1/2, right? Then we can apply the theorem 8.
Then you get the arc sine of 1/2.
So like the first
Which means that the limit when x approaches 1 of R sine of this guy is exactly the same as R sine of the limit when x approaches 1 of 1 minus square root of x over 1 minus x, right? Which is,
The arc sine of 1/2.
thank you. And it will be pi over 2. Yes, very good. Thank you. One half 30, yeah, 30, yes, pi over 6. Good job. Okay, that's it. I'll see you tomorrow. Thank you.